Hello everyone, today I'm going to talk about ionic bonds with covalent character. The important part of this concept is the factors affecting the degree of covalent character. First, it is the polarizing power of cation. What does this mean? And the polarizing power of cation actually depends on the charge and cationic radius. The higher the charge and the smaller the cationic radius, the higher the charge density. So basically, what relates to the polarizing power is the charge density. The charge density is what basically the charge density. Yeah. This why is it not highlighting well? There you go. And then the higher is polarizing power. Okay. Now, yeah, this is how it is. Then it's the polarizability of the anion. Okay, the cation polarizes the anion. So the polarizability of anions, it depends on the charge and anionic radius. We use the same formula here. We use the same formula as shown here. Okay, so it depends on the charge and anionic radius. The higher the charge and the larger the anionic radius. Okay, so this one, right, is not entirely about the charge density being directly proportional to the ionic charge. Because if that's the case, right, then the ionic charge should be less and the ionic size should be larger. So try not to have a misconception that it is directly proportional. It depends on the charge. The higher the charge is always better. What we should be looking at is the ionic size. Okay, the ionic size. The ionic charge we just treat the ionic charge as a constant, I mean, not really a constant, since a higher ionic charge would change the degree of it. But in that sense, you have to focus on the ionic size, okay? But no, always know that the higher the ionic charge, the more polarizable it is, or the more polarizing power it possesses. So the higher the charge and the larger the anionic radius, the more polarizable it is. Now, generally, bonding tends to be covalent if the cation is small, the anion is large, and the charges on both ions are high, as what I've mentioned before. Now let's look at an example. Explain why AlF3 is ionic while AlCl3 is covalent. Now, with AlCl3 plus has high charge density. Why? Why does it have such? Let's look at it. Al is small, and also it has a high ionic charge. Okay, since they both have the same cation, we don't really have to compare the ionic size of it, but just about the ionic charge, because has high charge, hence high polarizing power to distort the electron cloud. Now, this is a very important statement: distort the electron cloud. Okay, you must know this statement: distort electron cloud of the highly polarizable Cl minus ion. Why is the Cl minus highly polarizable? Because Cl minus, we know, is very large. Okay, Cl minus has a large ionic radius, although it doesn't have as much of a high of an ionic charge. But if you look at the periodic table, the Cl minus is legit damn large. Yeah, so because it has such high polarizing power to distort electron cloud of the highly polarizable. So everything is highly polarizable, and everything can polarize very powerfully. So it becomes predominantly. This is a very important statement. Yeah, you need to know. Keyword. Like Mr. Zhou said, always talk about the keywords. Predominantly covalent. Okay, predominantly covalent. Now F minus has a small ionic radius, then Cl minus, and is less polarizable. So distortion of the electron cloud. Again, distortion of electron cloud. Keywords. When you're doing your practice, right, always mind the keywords. Okay, you can understand the concept very well, but if you leave out the keywords, right, you won't get the marks. Okay, so F minus anionic radius, so less polarized, so distortion of electron cloud is less significant, so it predominantly ionic. Okay, and this just to note for the halogens, right, Cl, Br, and iodine is covalent compound. Okay, anything above it, like fluorine, is not a covalent compound, it's ionic. So this is it for ionic bonds with covalent character.